Welcome to MetaMinds Academy. This is a lecture series on matrices. In this particular lecture, we are going to learn what is a system of linear equations and how to solve the system of equations. So this is a system of m linear equations in how many variables? N variables. x1, x2, xn. So we have to find these n values, therefore they are called unknowns. So m linear equations in n unknowns x1, x2, xn. Always write the constant term on the right hand side for convenience. So if you take the matrix a11, a12 and so on, a1n, that means the coefficients. You write all the coefficients of xi's into a matrix, right? Then we call it a coefficient matrix A. The system can be written as Ax equal to B, right? This is called matrix equation. Matrix equation of the corresponding system of equations. So what do you mean by consistency? Consistency is existence of the solution. If a system is consistent, that means the system has a solution. System has a solution. If it has a solution, it can be unique or infinite. Inconsistent means what? No solution. So coming to the procedure to test the consistency of a system of equations in n unknowns is, you are given the system Ax equal to B. Write the augmented matrix. We call this matrix K as augmented matrix. What does it mean? You have to write the matrix A, coefficient matrix A, and the column matrix B side by side. And if you want, you can make a separation between A and B. Otherwise, you can do it as it is. Right? I use a separation between A and B. Then find the rank of A and name it as R. Find the rank of K, augmented matrix, and name it as R dash. So if the condition is, if R is not equal to R dash, rank of A is not equal to rank of K, then the system is inconsistent. The system has no solution. If R equal to R dash and also equal to n number of unknowns, then the system is consistent. That means it has a solution, and the solution is unique solution. If R is equal to R dash but less than n, less than number of unknowns, then the system is consistent. Still it is consistent and it has infinite solutions. It has infinite solutions. So when the system is consistent, if R equal to R dash, right, the system is consistent. R is not equal to R dash, system is inconsistent. So here is a classification of the system of equations. A system of equations Ax equal to B can be classified as non-homogeneous system of equations and homogeneous system of equations. So when do you say the system is homogeneous system of equations? If right hand side B is equal to 0, that means all B1, B2, Bn, Bi's are zeros, we call the system as homogeneous system of equations, Ax equal to 0. And the homogeneous system of equations is always consistent. Because it is consistent, it may have unique solution or infinite solutions. And if it is a unique solution, then it must be equal to 0, x equal to 0. That means all x1, x2, xn equal to 0. That means the 0 solution is the only solution, right? If it is infinite solutions, we need to find it manually. And if the system of equations is a non-homogeneous system of equations, when do you call it non-homogeneous? Right hand side B is not identically equal to 0. That means at least one of Bi's is non-zero. We call the matrix as a non-zero matrix. Non-zero matrix. If it is a non-homogeneous system, then you may have two possibilities, consistent and inconsistent. If it is consistent, it can be unique solution or infinite solutions. If it is inconsistent, it has no solution. Now let us solve some problems based on this concept. The first problem is test for consistency and solve. You are given a system of equations, 3 equations and 3 unknowns x, y, z, right? So what we need to do is, first of all, we convert this matrix, the system of equations, into matrix equation. So write the coefficient matrix first. 1, 2, 3. 1, 2, 1 are the coefficients. 1, 2, 1. Here x, y, z are the unknowns. Here right hand side you have 3. 2, 3, 2. 3 minus 5, 5. This is coefficient matrix. Right hand side 3, 5, 2. 3, 5, 2, right? So it is nothing but Ax equal to B. So what is the matrix A? This is matrix A, this is matrix B. So what we have to do is, first of all, we write the matrix, augmented matrix K, which is AB. The matrix A and matrix B, we write it side by side. So what is matrix A? 1, 2, 1, 2, 3, 2, 3, minus 5, 5. And with a separation, I write the matrix B, 3, 5, 2. For better understanding, I use the separation. You need not use this separation also. Now we reduce this matrix to its echelon form. Right? So how to reduce? First of all, we make these two entries 0 using this particular entry, using R1. So R2 implies R2 minus 2R1, 2 minus 2 is 0, and R3 implies R3 minus 3R1. So how does K transform? K is similar to, here there is no change in the first row. Second row, this minus 2 into this, 3 minus 4, 2 minus 2, 5 minus 6, 5 minus 6. Coming to third row, this minus 3 into this, 3 minus 3, 0, minus 5, minus 6, 5, minus 3. And this minus 3 into this, 2 minus 9. So now next target is to make this entry 0. So how to make this entry 0? Using this one only, because this entry is not going to, this 0 is not going to impact this 0. So we use R2 only to modify R3. So how to modify it? R3 minus 11 R2. So how does K transform? There no change in the first row again. Second row also no change. Third row 0 minus 0, minus 11 plus 11, 2 minus 11 into 0, 0. So 2 minus 0, 2, minus 7 plus 11. Minus 7 plus 11 is 4. Right? Now you cannot further reduce because you cannot make this entry 0. Right? So if you try to make this entry 0 using this, these two entries will be affected. So it is already in the echelon form. So once it is in the echelon form, what we have to do is, we should observe what is the rank of matrix A and what is the rank of matrix K. So if you hide this, the remaining, this part is matrix A, and what is the rank of this matrix A? It is 3, because there are 3 non-zero rows in A. 3 non-zero rows in A. Therefore, the rank of A is 3. This implies rank of A is 3, which we name it as R. And if you see the matrix K, also rank 3, because you have 3 non-zero rows. 3 non-zero rows. Therefore, rank of K is also 3. So, rank of K, augmented matrix, is also 3. And what are the number of unknowns? Number of unknowns is x, y, z. It is also 3. Therefore, R equal to R dash equal to N equal to 3. All are equal. So what does this mean? When R equal to R dash, the system is consistent. When it is equal to N, system is consistent and it has unique solution. Unique solution. Therefore, it has a unique solution. Now, test for consistency and solve. Right, you are asked to solve the equations also. So let us solve the system of equations. So once you arrive at this position, this step, you can write the equations x plus 2y plus 1z. Right, using this matrix K, the reduced equations are x plus 2y plus z equal to 3. From the second row, there is no extreme, minus y plus 0z. Minus y plus 0z equal to minus 1. There is no x, there is no y. Here 2z equal to 4. 2z equal to 4. So from this, y is equal to 1. From this, z is equal to 2. If you substitute y equal to 1, z equal to 2 in this, we will get x plus 2 into 1 plus 2 equal to 3. X equal to 3 minus 4 minus 1. Therefore, the solution is x equal to minus 1, y equal to 1 and z equal to 2 is the required unique solution. So coming to the second problem, you are given a system of equations, 3 unknowns, 3 equations, and asked to test the consistency and solve. So how to express this? First of all, we write the coefficient matrix 4 minus 2 6, 1 1 minus 3, 15 minus 3 9 into xyz equal to 8 minus 1 21. Right? Now what we have to do is next one, this is Ax equal to b, and we write the augmented matrix. The augmented matrix K is writing A and B side by side. So this is K equal to, you write the matrix A 4 minus 2 6, with a separation write the matrix B. Here it is 1 1 minus 3, 15 minus 3 9, and matrix B is 8 minus 1 21. Right. So next step is we convert this matrix, we reduce this matrix into echelon form. For that, if you have 1 here, it is easy, the job becomes easy. So I swap the first two rows, you have 1 here and you have 4 here, right? So if you have 1 in the A11 place, the job becomes easy. Therefore I swap R1 and R2. So K is now similar to 1 1 minus 3 minus 1, 4 minus 2 6 8, 15 minus 3 9 21. Now we have to make these two entries 0. So how to make these two entries 0? R2 minus 4R1. So we convert R2 as R2 minus 4R1. And R3, how to get 0 here? R3 implies R3 minus 15R1. 15R1. Right? So therefore, how A will be reduced? K will be reduced. There is no change in the first row. And here you have 0, 4 minus 4, this minus 4 into this, minus 2 minus 4, minus 6, 6 plus 12, 18, 8, minus of minus 4, 8 plus 4, 12. And coming to the third row, this minus 15 into this, 15 minus 15, 0, minus 3, minus 15, minus 18, 9, plus 45. It is 54, 21 minus of minus 15, 21 plus 15, 36. Right. So if you observe, actually here the next target is to make this entry 0, right? Now R3 implies, how to get 0 here? R3 minus, both are negative signs, so we take only negative sign only, subtract. R3 minus 3 into this, 3R2. Then K becomes 1 1 minus 3 minus 1. No changes to second row also. Third row is R3 minus 3R2. Here it is minus 18 plus 18, 0. So in the process of making this entry 0, if you observe, these two entries are also becoming 0 automatically. That means 54 minus 3 into 18, 54 minus 54, 0, 36 minus 36, 0. Right? We tried to make this entry only 0, but these two entries also became 0. Now if you hide this, the remaining is matrix A. In the matrix A, the rank is 2 because we have only 2 non-zero rows. The rank of A is 2 because it is already in the echelon form. Rank of A is 2, which is R, and rank of K. What is the rank of the augmented matrix, entire matrix? In this matrix also, you have only 2 non-zero rows. Therefore, that is also 2, which is R dash. But what is n? Number of unknowns is 3. Therefore, R is equal to R dash but less than n in this particular case. Okay. So, in this particular case, what happens? The system is still consistent and has infinite solutions. Infinite solutions. So, let us write the reduced equations. Here you have x plus y minus 3z equal to minus 1 because we are also asked to solve, right? We try to solve this. Minus 6y plus 18z equal to 12. So we have only two equations, third equation is not there. So now we have three unknowns and two equations only. So you can solve for only two variables. The third variable should be chosen. That is how you will get infinite solutions. So from the second equation, you will get, if you divide it by minus 6, y minus 3z equal to minus 2 you will get. So from this, you can write y equal to 3z minus 2. 3z minus 2. And if you write y in place of y here, what you will get is, therefore x plus 3z minus 2 minus 3z equal to minus 1. Right? So 3z gets cancelled and x equal to 2 minus 1, 1. So luckily we got x equal to 1, y equal to 3z minus 2. But what about z? Z is not obtained here. That variable we have to choose some value for this variable. Let us choose some t. Let us choose some value t for z. Then what happens to y? Then x is already 1, y is 3t minus 2, z is t. So t can be any number. I write here. You can choose any value for t. That is how you will get infinite solutions. X equal to t, x equal to 1, y equal to 3t minus 2. Z we have chosen it to be t, some value, some real number. So how many real numbers you can choose for t? Infinitely many values for t. Therefore, for every value of t, you will get a different solution. You substitute t equal to 1, you will get 1, 1, 1. You substitute t equal to 0, you will get 1 minus 2, 0. So that is also solution. So therefore, infinite solutions. So coming to this problem, test for consistency and solve the given system of equations. So what is the given system of equations? If you observe, right hand side all are zeros. All BI's are zeros. Therefore, it is a homogeneous system of equations. So let us write the matrix equation 1, 2, 3, 3, 4, 4, 7, 10, 12 into xyz equal to 0, 0, 0. That means the given system is of the form Ax equal to 0. Because right hand side is 0, it is a homogeneous system. And you are asked to find a test for consistency. You need not test because a homogeneous system is always consistent. You write simply a homogeneous system of equations is always consistent. Therefore, it has a solution for sure. Right, what we have to test is whether it is unique solution or infinite solutions. Here you need not write the augmented matrix like in the previous problems. Just write the matrix A. Take the matrix A 1, 2, 3, 3, 4, 4, 7, 10, 12. Right. Find the rank of the matrix A. When it is a 3 by 3 matrix, you need not reduce it to echelon form. You just find the determinant of the given matrix. And what is the determinant of this matrix? If you find its determinant is -2, you will get the determinant of the matrix is -2, which is non-zero. Because the determinant is non-zero, A inverse exists. This implies A inverse into Ax equal to 0. A inverse into 0 means x equal to 0 is the only solution, unique solution. So, when determinant is non-zero, you have unique solution that should be zero solution. That means x equal to 0, y equal to 0 and z equal to 0 is the only possible solution for the given system of equations. So, coming to this problem, this is also a homogeneous system of equations because right hand side are all zeros. Let us convert this into matrix form 4, 2, 1, 3 because you have 4 variables here, 4 unknowns x, y, z, w. Okay. So, write the coefficient matrix 6, 3, 4, 7, 2, 1. There is no z term in this. So, write 0, coefficient is 0, coefficient of w is 1, x, y, z, w, 4 unknowns, but you have only 3 equations. You have only 3 equations. So, this is Ax equal to 0, a homogeneous system. So, this system is always consistent as it is a homogeneous system. We need to test whether we have only unique solution or infinite solutions. Because when number of unknowns is 4 and you are given only 3 equations, less than 4 equations, definitely you are going to have infinite solutions only. Okay. So, let us see. Now, write the matrix A 4, 2, 1, 3, 6, 3, 4, 7, 2, 1, 0, 1. Now, let us reduce this matrix to echelon form. So, how to reduce? Make these two entries 0. So, how to make? R2 implies 2R2 minus. How to get 0 here? Using this one. You can multiply. The LCM is 12. So, make it 12 both. 2R2 minus 3R1. Right? And how to make this one 0? R3. 2R3 minus R1. 2R3 minus R1. So, simply A will be reduced to no changes in the first row. 0. 2 into this minus 3 into this. 2 into this 6 minus 3 into this 6. 0. 2 into this 8 minus 3. 5. 2 into this 14 minus 9. 5. Next. 2 into this minus this. 0. 2 into this 0. 2 into this minus 1. 2 into this 2 minus 3 minus 1. Right. Now we observe you can make this entry also 0 and this also becomes 0. These two rows are right. So what you have to do is R3 implies R3 5R3 plus R2. You multiply this by 5 and add to this. What you will get is no changes in the first row. 0, 0, 5, 5, 0, 0, 0, 0. See, the rank of A is 2 because you have only 2 non-zero rows, but you have 4 unknowns. 4 unknowns. N is 4, right? So, because it is always consistent, it must have a infinite solutions only. So, let us write the system of equations. Rank of A is equal to 2 implies infinite solutions, obviously. And let us write the equations. 4x plus 2y plus z plus 3w equal to 0. 5x plus 5z, sorry, 5z plus 5w. 5z plus 5w equal to 0. From this, you can write z equal to minus w. Z equal to minus w. You put z equal to minus w in this first equation, you will get 4x plus 2y plus z plus plus 3 into, I write this as minus z, w equal to minus z, I write minus z here, so that you will get 4x plus 2y, z minus 3, 1 minus 3 minus 2, z equal to 0. This implies 4x plus 2y equal to 2z, or 2x plus y equal to z. As n minus r is 2, two variables are independent and two variables are dependent. If you observe 2x plus y equal to z and z equal to minus w, here z is depending on w. If you choose a value for w, you need not choose a value for z. You will obtain the value of z. Okay. So we have to choose another variable between x and y. Okay. Therefore, choose w equal to t1 and I choose y equal to t2. Therefore, what happens? Because w is t1, z becomes, this implies z becomes minus t1 and 2x plus t2, 2x plus t2 equal to t1 implies 2x equal to t1 minus t2. So x equal to t1 minus t2 by 2, y equal to t2, z equal to minus t1, it is obtained, w equal to t1 is chosen. So this is the set of solutions, infinite solutions, where t1 and t2 are some real numbers. In the next class, we will learn some more problems based on consistency and inconsistency. Please like this video, share it with your friends, and comment your feedback in the comment section. Thank you so much. Please subscribe to my channel if you have not subscribed yet. Thank you.